If you've looked at bulbs, you may have seen something written like this: 10 watts or 100 watts. What does this wattage mean, and how do we calculate it? That's what we'll learn in this video. So this number, 10 watts, actually represents something called electric power. So power in general, electric or otherwise, is a measure of how much energy is consumed or delivered in unit time, per time. So its units become, let's look at its units now. The unit of energy is joules, the unit of time is seconds, and joules per second is what we call as watts, which we represent by W. It's named after the scientist James Watt. So over here, 10 watt means 10 joules per second. 10 joules per second. This means that this bulb consumes 10 joules of electrical energy every second. And when I say consume, what I really mean is that it converts electrical energy into some other form. In this example, it could be heat and light, but there could be other examples. In speakers, we convert it into sound. In fans, we convert it into rotation or mechanical energy, and so on. Here's a list of power ratings of typical devices that we might find in our houses. For example, air conditioners have pretty high power ratings. They can be as high as 1,000 and go all the way up to 2,000 and 2,500 watts. 1,000 watt means our air conditioner consumes 1,000 joules of electrical energy every second. But if you look at your mobile phones, for example, they consume extremely tiny amount of power, less than 5 watts. Now here's a question: where do these energies come from? I mean, it has to come from somewhere, right? Well, you may guess that in mobile phones and laptops, these energies are delivered by the batteries. But in bigger circuits, like in our domestic circuits, then the energy is delivered by the large generators in the power stations. And again, what I mean by deliver here is that these things convert some other form of energy into electrical energy. For example, batteries convert chemical energy into electricity. And you may learn more about that in chemistry. Generators convert rotational mechanical energy into electrical energy. And we'll learn about this fun stuff in future videos. And guess what? For the electricity that we get at our houses, we have to pay for the energy that we consume. We don't pay for voltage or current, but it's the energy that we pay for. So it's important to be able to calculate electrical power. And so that's what we'll do now. We will see how to calculate electric power in terms of voltage and current. So let's take an example. Imagine we have a bulb through which 2 amps of current is passing. And let's say the potential difference across the ends of the bulb is, let's say, 5 volts. Now, looking at these two numbers, let's see if we can figure out what's the power consumed by this bulb. To do that, we'll first recall what current and voltage means. 2 amperes means 2 coulombs per second. This means through any point in the circuit, 2 coulombs of charge are passing by every second. 2 coulombs per second. And what does voltage mean? Volt is joules per coulomb. This means that when a coulomb moves across the bulb from one point to another, it delivers 5 joules of energy to the bulb. So what we know from these two is that for every coulomb that passes by, bulb consumes 5 joules of energy. And in 1 second, 2 coulombs are passing through it. So using these two numbers, can we calculate how much energy, how many joules of energy is being consumed by the bulb every second? Pause the video and see if you can try and do this yourself. All right, let's do this. Let's write that down over here. I'm going to wait for 1 second and see what happens. In 1 second, I know 2 coulombs of charge will pass through. But each coulomb will deliver 5 joules of energy. So 2 coulombs will deliver 2 times 5, 2 times 5, 10 joules of energy. And therefore, in 1 second, 10 joules of energy will be delivered to the bulb, and so the power would be 10 watt. And if you look at the units also, we'll get the same thing. Notice 2 coulombs are passing every second into 5 joules per coulomb. The coulomb cancels, and we get 10 joules per second, which we call as 10 watts. Now, if the current was, let's say, 3 amperes, then in 1 second, 3 coulombs would pass by, and so this would be 3. On the other hand, if the voltage was, let's say, 20 volt, then for every coulomb that passes by, 20 joules of energy would be delivered to the bulb, and so this would be 20. So can you see that in order to calculate power, all we are doing is multiplying the current with voltage. And so in general, we can now write that power, or electric power, is just the product of voltage and current. So if you know these two, just multiply them and we get electric power. Also, if we know the power rating of a device and we know what is the voltage across that device, then using this equation, we can calculate what the current would flow through that device. So to summarize what we learned, in any electrical circuit, there is a source, like batteries or generators, which will deliver electric power, and there are devices which consume electric power. And we define in general power as how much energy is consumed or delivered per second, and we measure it in watts. And to calculate the electric power delivered or consumed by any device, we just multiply the voltage across that device and the current to that device. And I like to remember this by using a saying in electricity: with great power comes great voltage and current.